Callbacks, promises, and async await are three answers to the same problem. Today we write one task in all three, so you can see exactly what each one fixed. We will look at error handling in each style and where it silently breaks, how to run work in parallel instead of one call at a time, and the two traps that make fast code accidentally sequential. Start with the version you have probably inherited at some point. 3 calls that each depend on the one before it. Fetch a user, then that user orders, then an invoice for the first order. Because the only way to know a callback has finished is to be inside it. Each step has to nest inside the last. Notice the error line. It is repeated at every level, and if you forget one, that failure disappears silently. Add a fourth step and you indent again. So there are 3 problems here. Every new step costs a level of nesting. Error handling is duplicated and easy to miss. And you cannot return a value out of this at all. You can only call yet another callback. Promises fix the shape of this, and they fix the error handling too. Here is the identical task as a chain. Each then receives the previous result and returns the next promise. So instead of nesting inward, we go straight down the page. The important part is what happened to the errors. One catch at the bottom handles a rejection from any step in the chain, because a rejection skips every then until it finds one, and finally runs either way, which is where cleanup like hiding a spinner belongs. There is one mistake almost everyone makes with chains. Look at this then. It calls get orders, but it never returns it. Without that return, the chain does not wait for the promise. It moves straight on, and the next then receives undefined instead of the orders array. The fix is one word. Return the promise, and the chain adopts it and waits. Now the version you should actually be writing today. Same 3 calls one more time. Await unwraps a promise and gives you the value, so each line reads like ordinary synchronous code, and the dependency between the steps is obvious just from reading top to bottom. 2 things to keep straight. The function is still asynchronous, so it returns a promise to whoever calls it. And await only works inside an async function or at the top level of an ES module. Anywhere else it is a syntax error. Error handling collapses into a plain try-catch. One catch covers a rejection from either await, and finally still runs whatever happens. One detail that catches people. Keep the await on that return inside the try. Without it, you hand the promise back before it settles, so the rejection escapes the try block entirely and your catch never runs. Now the mistake that quietly makes everything slow. These 3 requests do not depend on each other at all, but written like this, each await waits for the previous response before starting. 300 milliseconds, each becomes 900. Promise.all starts all 3 immediately and waits for the slowest, so the same work takes 300. The rule is simple. Sequential await is only correct when the next call genuinely needs the result of the one before it. If it does not, you are just queuing for no reason. For combinators worth knowing. All. When you need every result, and one failure should fail everything. All settled. When you want every outcome, including the failures. Race, when the first to settle wins, which is how you build a timeout. And any, when the first success wins and rejections are ignored until they all fail. Two traps, and both of them look completely fine. The first is a wait inside a loop. This is honest but slow, because each iteration waits for the last. Sometimes that is what you want. Usually it is not. The second one is genuinely broken. For each does not wait for the async function it is given, so it fires all of them and returns immediately. The array is still empty on the very next line. Both are fixed the same way, by mapping to promises and awaiting all of them together. So for rules, use sequential await only when the next call needs the previous result. Never hand an async function to for each. Always return the promise from a then callback. And every await needs either a try catch or a catch further up the chain. That is the whole arc callbacks nest. Promises flattened. Async await reads like normal code. Errors collapsed into one try catch, and promise all turned 900 milliseconds into 300. All of the code is in the description. Subscribe if you want more JavaScript deep dives like this one.